Imagine a world where electricity flows forever, with zero energy loss. A world with floating trains, super-fast computers, and power grids that never waste energy. Sounds like science fiction, right? Well, it's not. Welcome to the world of superconductors. And today, we're diving into the search for a game changer, the room temperature superconductor. If you're new to the channel, hit that subscribe button because here, we explain science in the simplest way possible. Superconductivity is a phenomenon where a material, when cooled below a certain critical temperature, completely loses its electrical resistance. That means electricity flows without any loss of energy as heat. Normally, when you send current through wires like copper, some energy is always lost. It turns into heat, which you may have noticed if your phone gets warm during charging. But in a superconductor, that doesn't happen. Zero resistance. 100% efficiency. This strange behavior was first discovered in 1911 by Dutch physicist Heike Kamerlingh-Onnes. Since then, superconductors have been studied for over a century. But there's a catch. 1. Extremely low temperatures. Most superconductors only work at temperatures near absolute zero. That's around minus 269 degrees Celsius, or 4 Kelvin. At that point, you need liquid helium to cool them, and that's very expensive. 2. High pressure. Some newer materials show superconductivity at higher temperatures, but they need extremely high pressure, like hundreds of gigapascals. That's more than the pressure at Earth's core. 3. We don't fully understand it. Despite all our research, the exact mechanism behind superconductivity, especially high-temperature superconductivity, is still not fully understood. That makes it tough to design new materials on purpose. Now imagine this. What if we find a material that can do all this at room temperature? No extreme cooling, no crazy pressure. That would change everything. Here's how. 1. Ultra-efficient power grids. No more energy lost in transmission. Power could travel across cities and countries without heating wires. That could save billions in energy. 2. Super-efficient electronics. Phones, laptops, and even supercomputers could run faster and cooler with superconducting components. 3. Magnetic levitation, maglev. You've seen those floating trains in Japan and China. They run on superconducting magnets. Imagine cheaper, faster, and silent trains all over the world. 4. Medical imaging and MRIs. Superconducting magnets are used in MRIs. A room temp superconductor would make these cheaper and more widely available. 5. Quantum computing. Superconductors are the backbone of quantum computers. A stable, room temperature version could accelerate this tech revolution. 6. Fusion energy. Magnetic confinement for fusion reactors depends on strong superconducting magnets. Room temp superconductors could finally make fusion more viable. Let's talk real science. What's happening right now? LK99. In 2023, a team in Korea claimed they had discovered a room temperature superconductor called LK99, made from modified lead apatite. The announcement went viral across social media and scientific circles, but replication efforts from other labs showed no superconductivity. Turns out, it was likely a measurement error or misinterpretation. Disappointing, but still progress, because it sparked renewed global interest. Other promising research. Other labs are experimenting with hydrogen-rich materials under high pressure. Some are achieving superconductivity at around 15 degrees Celsius, but still under extreme pressure. Not quite there yet for practical use. Theoretical research. Scientists are also exploring the quantum mechanics of superconductivity, trying to predict what kinds of structures or elements might lead to the magic combination of zero resistance at room pressure and temperature. If, or when, a room temperature superconductor becomes real, here's what the world might look like. Cities powered with near-zero loss. Transport systems floating on magnetic cushions. Hyper-efficient chips and electronics. Access to powerful medical tools worldwide. Quantum computers in everyday life. Cleaner and cheaper energy from fusion. It's not just another science topic. This is a potential technological revolution. So, what do you think? Will we see room temperature superconductors in our lifetime? Or is this just another overhyped dream? Drop your thoughts in the comments. Don't forget to like, subscribe, and hit the bell for more mind-blowing science made simple. Thanks for watching and keep exploring.